$1 million in prize money is on the line in the first ever head-to-head autonomous racing event to be held at the Indianapolis Motor Speedway in October. UVA Engineering's Cavalier Autonomous Racing Team will compete with other top universities for bragging rights as the best autonomous racing team in the world. Buckle up as I, your host, Chris Tyree, and UVA Engineering professor, Madhur Bahel, take you in the shop, under the hood, and around the track in this new world, pushing autonomous vehicles to their limits.
Hi there, I'm delighted today to be joined by some of my team members from the Cavalier Autonomous Racing Team. These are the students, they are the real rock stars who make the team look good, and they've been behind the success and our journey into the Indy Autonomous Challenge for the past year. So I thought it would be a good idea to have you, talk to the team, let them introduce themselves, and then we can get into some of the, nitty-gritty stuff of what their experience has been taking part into this competition and being, working together for the past year on this very, very difficult challenge of high-speed, unprecedented head-to-head autonomous racing.
Let's go.
My name is Arvind Anand. I'm a third-year undergraduate in the School of Engineering and Applied Sciences, and I study computer science.
My name is Jingyun Ning, and I'm third-year PhD candidate in Department of Computer Engineering.
I'm Trent Weiss, and I'm a fourth-year PhD candidate in the Department of Computer Science.
I'm Kenny Brown. I'm a third-year PhD student in Mechanical and Aerospace Engineering.
I'm Aaron Harder. I'm a third-year PhD student in the Department of Computer Science.
So maybe I think a good place to start is to look back for the past year. We have been working on first the simulation part of the competition. You guys were working remotely as a team and got so much done. And now, we are transitioning into the phase of the competition where we'll have access to the full-scale race car that we actually spent some time in June at Indy itself. So Arvind, why don't you reflect upon what that experience has been for you, and what are you looking most forward to in the coming months?
Like, actually being in front of the car and working on it is totally different. It feels more tangible, and it's a lot more exciting, I guess. The sim race was cool in some ways, in that it's more about the code and less about the car, and you got to collaborate with your team and test out different algorithms. But it was like a totally different paradigm actually going there and playing with the car itself. You got to learn more about the systems on board. You got to learn more about how you might possibly tackle the problem. And I'm definitely most looking forward to the race. I'm looking forward to the environment, being around all these cars that are souped up with the latest of sensor technology. I just can't wait to see them whiz past us at 200 kph. That's just gonna be out of this world. It'll be the height of my life. I feel it'll be the apex.
Yeah, I hope we get to see that. There's a lot of work to be done, right?
Yeah. A lot of work. The real cars have a lot more failure modes, as Arvind touched on, right? So a lot more things can go wrong, and we have to be ready for that. But it'll be an exciting challenge, right? Getting these cars to the point where they actually can zip past us at 200 kph is going to be both fun and challenging, and fun because it's challenging, right?
But what do you guys think is the biggest challenge in going from simulation to the real car? Physics
realism, right? The real car, there's so much more uncertainty in how actual physics works than what the simulator idealizes. So just designing our algorithms to be able to handle that is going to be a significant hurdle.
Right.
And also there are a lot of things, a lot of systems that are making this thing work, and in the simulation you sort of took everything for granted. Everything from odometry, your current pose, but in the real car we still have to deal with this whole network setup, and we don't know what the latency on that is, or whether or not the GPS can keep up with the high speeds, or whether or not the camera feed is too rocky from going that fast, and we can't do inference properly. And we don't know if the LiDAR will malfunction halfway through it, or if the mesh network is capable of transmitting all that data at real time at the speeds that we want for analysis. I mean, there's just so many things that we took for granted that we just can't take for granted anymore.
Yep.
And we also have to make sure that all of our ROS code is running at speed. With the simulator, it wasn't running in real time. Now that we're running with a real car, we have to make sure everything is being processed fast enough, and that it all gets done in time.
Yeah.
Yeah, I would say one of the, like from my vantage point, I've seen the group grow in recent months. We started with very tiny, doing this on nights and weekends, and then we have grown now to a dozen or more students who regularly participate. I know some students are busy with their internships and other stuff over summer. From what I saw was, everybody came in at a different level. Someone already knew about autonomous racing, like Trent is doing that for his doctoral research, for example. Aaron is also working on similar problems. And then some were, have their expertise in, say, mechanical systems like Kenny does. So, but what I've seen is everybody's normalizing to sort of that base joint understanding, right? So, as computer scientists, we have learned about engine dynamics, Kenny. That's not something we cared about or spent time and energy understanding. And so what has been it like for you from the other side, non-CS side, if I might say?
Yeah, absolutely. It's been a great experience. It's amazing how much you take for granted when you're driving a vehicle. So I've driven a bunch of race cars over my life, and I'd never imagined how much is actually happening in the driver's mind, how many things you're taking account of, and like teasing all those little bits out into a computer that can do all these things is incredible. And that you guys are doing this is amazing to me. I've learned so much just trying to absorb from you guys and try to lend some of the mechanical context, but I feel like I've just gained a world of insight from you guys. It's been a great experience.
Well, it's been the same for us. I mean, you are our in-house race driver. So I think we've shared a bunch about where to position the car, when to be aggressive, when to back off.
Yeah.
Because that's really the big challenge, right? Like we are designing this AI driver, but without the experience of a regular driver who has decades of experience knowing how to operate a race car.
Yeah, I mean, racing per se has been solved, and that humans have been doing it for decades, right? Training an AI to do it is a totally different ballgame, right? And often the best place to start is to think about, well, how does a human do this, right? They seem to be pretty good at it. We've been doing it for a while, so if we can train our algorithm to behave as an expert driver like Kenny, then that's a pretty good baseline.
So Jinian, you were the TA for the F110 autonomous racing course for the past semester. In fact, I think Arvind was in that course as well. So maybe you can talk a bit about how that course was for you and how the course was organized a little bit, because a lot of the intention was to use small scale racing platforms as a way to educate the students about these problems of perception, planning, and control that we've been discussing.
Yeah, of course. Yeah, so first of all, because of the special situation, the COVID thing, so this year's our course is purely like online course. So the totally different is that our student this year can now access to the really hardware, the F110 car, which is a big, a little bit a shame, but the courses were still, I mean, really interesting, really fun for me. Actually, that was the first time for me to actually take that course and actually be the TA. I think Vernon, he was like being totally responsible for our simulator, the F110 simulator, which our student can get access to, like operate the cars using ROS and Gazebo simulator. But I think there's some like similarities between our F110 cars and actually Indy cars. It's like first of all, you need to use ROS as the operating system to do all the to do all the commands to translate to your cars.
Yep.
And second one, I think you also need to like not for this year, but previous year, you also need to worry about the hardwares, like how you assembling those cars. Like it's all the students will also like face challenges like what we have faced in the Indy car, like how hardware was actually working on that.
Yeah, I agree. I think the autonomous IndyCar is just the 1-to-1 version,
Yeah.
whereas we teach the 1/10 version for our course.
And that was the same fun to us.
Yes, that's correct. We have 20 cars first of all, so we can do a lot more than just with a single car.
Of course. Yeah, it's scaled down, but a lot of the challenges translate nicely, right? It's like, if a LiDAR randomly goes out, you have to be able to handle that, right? Or if a camera suddenly goes out, right? Just designing an algorithm that can handle the fact that this hardware is not perfect and it's going to fail in a long enough timeline is something that will transition nicely to the full-scale car. So what do you think was the biggest challenge that the students had on the 1/10 scale cars? Like what did they struggle with the most?
I think Arvin is the best one.
I was a student for that.
Was he a good TA? Let's start there.
I have some notes about that. you did well. Thank you, Jin. You're doing a great TA. I think the hardest thing was I guess getting started and harnessing all this information that we learned and saying, okay, now we have to make this thing work. That was pretty hard. I guess it would getting the car to behave. So theoretically, you understood it all, right? You understood, okay, PID, pretty self-explanatory, using the LiDAR to detect the wall really easy. I know how this works. The math makes sense. But when you actually code it and you play with all these different parameters and coefficients that have to that make or break how your car works,
Sure.
that's the hardest part because it's not theoretical. You just throw your theory out of the window. You're just okay, let's just press some buttons and see what works. It's just tuning, and I think that was the hardest part. Also understanding how one parameter affected how the car performed, and trying to find the correct set. And at the end of the day, I talked to a couple people that I knew in that class, and everyone's implementation was just a little bit different. There's not a right way to do it.
You said a little bit different. Was there a common thread?
I mean, yeah, you had to use wall following, you had to use PID, you had to use follow the gap to pass through obstacles. But a lot of the way we implemented our final project was we just took a set of waypoints and we mapped the set of waypoints as a pseudo race line. And whenever we'd come, so we'd have a set that would determine whether or not you would turn left or turn right. But then when you would come to a certain point, we knew that there was an obstacle there. We would turn on and follow the gap algorithm and stuff. And that was our unique approach. But some other teams didn't do that. They did kind of a hybrid wall follow, hybrid follow the gap sort of thing. It was just different. It was different.
Yeah, I was pretty surprised and amazed. I think both of us were. Because we actually thought that the track is pretty hard, and it was sort of by design. Apologies to the students.
It was the hardest one.
Yeah, we had a bunch of tracks to choose from, and we went with the hardest possible track. And no, it's not mean. I mean, I because it's at the same time I have confidence that the students have learned and they will persevere. So, but we were pleasantly surprised that every team did exceedingly well in the final race or the final exam. So it was, even though, as Jinyan said, we didn't have access to physical cars.
Sure.
I think it was still a meaningful experience, and we can't actually wait to get back to physical cars again next time the course is offered. Yeah.
It's fun class.
Super cool. I mean, this is a little more than an education here, right? I mean, there's $1 million. Has that started to tickle your brain a little bit? What you're after here?
A little bit.
It'll be tough. The competition is really,
Yeah, I mean,
really tough. There's some really good teams.
big prizes come with big competition, right? So, yeah, it's going to be tough to get that top prize, but I think we have a good shot.
Yeah, I think it's still too early to make a good judgment call. We haven't seen many of the teams yet. We only met a few other teams. And right now the atmosphere is very cordial because everybody's collaborating on getting the car to work. But I think there will be that weekend or that time when that switch will flip and we'll go into competitive mode. And we'll have our own team meetings and group meetings. But yeah, it is Yeah, it's a pretty tough competition. There are some really good competitors that we get a chance to race against them. So I was watching the Netflix Formula One documentary, right? You brought that up earlier, and I remember, I don't know in which season, there was someone who took a bet that if they finish on the podium, he's going to get a tattoo.
Yeah, it was the team principal for Renault.
I'll get a tattoo if we win this race.